Hello once again. Welcome to example 3 on the position vectors that I started with you in the previous videos. In the previous videos, we started learning about position vectors and we've done a detailed explanation on it, and also we've solved some examples on it as well in the previous videos. And I hope you understood it and you enjoyed the lesson as well. So this is a continuation to solve another example with you, okay, so that you get a perfect understanding of it. So as you can see from the board, I have example 3 on the board, okay, and I will encourage you to do or to watch the previous videos, because the previous videos lays the foundation, okay, the basic knowledge and understanding that you need about position vectors. I've done all those explanations in the previous videos, okay. That's why I keep on encouraging you not to miss out on any of the videos, okay. In this session we are just solving an example, okay, so that you get a good understanding of it. So if you want a detailed explanation, you need to watch the previous videos, okay. So do all to watch the previous videos to get a good understanding and foundation to be able to handle this session as well. And please don't forget to like the video and also share them after watching. And if you are watching for the first time, please do all to follow the page and also subscribe to my YouTube channel as well. Let's go ahead and take a look at the example 3 that I have on the board. Okay, let's read it together. It says that if point P is given to be minus 3,5 and point Q is given to be 3,5, find 2 multiplying the vector PQ. Okay, so we have to find 2 times the vector PQ. Okay, let me read it one more time. It says that if point P is given to be minus 3,5 and point Q is given to be 3,5, you should find 2 times the vector PQ. Okay, so this is a question that combines the multiplication of a vector by a scalar and also the position vector. Okay, and I've already taught you multiplication of a vector by a scalar in the previous videos, and also we just learned about position vector. So this question is a combination of the 2 of them, so we are going to apply it to solve this question. Okay, so first of all, let's write down the information given in the question. Okay, so let me write down my solution and let's solve it together. So I've been given the point P, okay, and I've explained to you from the previous videos that given a point, you can express that point as a position vector. So the point P given here, I'm going to write it as a position vector. So I have my P, point P, which is minus 3, 5. I'm going to express it as a position vector. A position vector simply means that a vector which starts from the origin. Okay, so we are going to write the point P as a position vector, which is going to be OP. And I hope you understand. I've explained this a lot in the previous video. So my OP will be equal to minus 3, 5. Okay, then we're given the point Q as well. So again, the point Q, I'm going to express it as a position vector. Okay, so my point Q as a position vector is going to be OQ. So my vector OQ will be equal to 3, 5. Okay, so that's the first step. Okay, and the question is asking us to find 2 times the vector PQ. Okay, so now I don't want you to get confused, so we are going to break it down. Okay, so let's find the vector PQ first, then we'll proceed and find the 2 times the vector PQ. I hope you agree with me. All that we want to do is that let's find the vector PQ. Then after we've gotten the answer for the vector PQ, then we are going to multiply that answer by 2, and that is going to give us 2 times the vector PQ. Okay, so let's start by finding vector PQ. So if I want to find vector PQ, we are going to apply the knowledge that we've had on position vectors. Okay, for me to get the vector PQ, I've explained to you that it's always the position vector of the last letter minus the position vector of the first letter. Okay, so the last letter here is Q. So the position vector of the Q is going to be OQ minus the position vector of the first letter, which is the P. So the position vector of the P is going to be OP. So minus OP. Okay, so that's how we go about it. Then from here, I just need to input my values to get my vector PQ. Okay, so I have OQ. OQ is 3, 5. So I put it there, 3, 5 minus OP. OP is minus 3, 5. Okay, so then we go ahead and simplify further. Okay, so my vector PQ will be equal to, now we are just going to apply the subtraction and addition of vectors that we learned. I've taught you that in the previous video, so we are applying that knowledge here. So let's go ahead and simplify. So 3 minus 3 is going to give me positive 6, because when two negative meets like this, it becomes positive. Okay, then 5 minus 5 is going to give me 0, and I hope you agree with me and you understand up to this point. Okay, so this is my vector PQ. But if you leave it like this, of course you are not done, so you will not get your full marks. Okay, so the question asks us to find 2 times the vector PQ. So now we need to multiply the PQ by 2 so that we'll get the 2 times the vector PQ. Okay, so let me continue from here. So to get my 2 times the vector PQ, it's going to be 2 times, we've gotten the value of vector PQ. Vector PQ is 6, 0. So I'll bring my 6, 0. Then we simplify. This is a multiplication of a vector by a scalar, which I've taught you in the previous video. So we are applying that knowledge to solve for this. Okay, so let's go ahead. So the 2 multiply the value here, and the 2 multiply the value down here as well. Okay, so you have 2 times 6, which will give you 12. 2 times 0, it will give you 0. Okay, so that becomes our final answer, and that is we finding for 2 times vector PQ. The answer is 2, 0. Okay, I hope the explanation was clear enough and you understood it as well. Please don't forget to like the video. Okay, please like the video for me, and also share them as well. And if you're watching for the first time, please do all to follow the page and also subscribe to my YouTube channel as well. I'll see you again in another video whilst we handle another aspect of the vectors. Bye bye.